Welcome in Cairo. Today I am going to continue the applications of the total internal reflections, a very important application we are see it in our life, which is mirage. What's meant by mirage? Before the definition of mirage, we have to see carefully in this diagram. Here we have here a palm tree. This palm tree sends a light ray. Then this light ray is refracted, as you see, then reflected more. After that, after reflection, it is totally reflected. So we see this palm tree is inverted. Why? What is the reason? What is this phenomenon? Does it happen in our life? Yes, of course it happens in our life. How? Please tell me. Okay, I tell you. Let's see. First, here, as you know, here the Earth's surface, okay? Above the Earth's surface, the air layers are very, very hot. As you go up in the upper layers of air, the temperature of air decreases gradually. So the upper layers are very cold. The lower layers are very hot. And between them, there is a gradient of temperature. So when a light ray passes from hot air, cold air to hot air, from denser medium to a less dense medium, the light ray is refracted away from the normal, as you see in the first case. Then in the second case, the light ray is refracted away from the normal until when the light ray here falls in angle of incidence greater than the critical angle, the light is not refracted. The light is totally reflected. As you see here. So we see the objects, yes, are inverted. We can see water in deserts. When you are with your father and you ride the car and you see the water in front of you, and when you come close, you didn't find water. Why? This is, yes, the reason of mirage. It is mirage phenomenon. So what's meant by mirage phenomenon? Mirage is a natural phenomenon. Observe it on hot days, responsible for the wet appearance of paved roads in summer, of the illusion seeing water in deserts. That's for the definition of mirage. The mirage can be explained as follows, and as I told you before. First, on very hot days, the air layers above the ground get hotter, optically lesser dense, lower refractive index than the upper layers. As a light ray from an object such as the sky or a palm tree travels from the upper layers to the lower layers, what will happen? Yes, it refracts away from the normal and keeps deviating, taking a curved path. After that, accordingly, the angle of incidence increases from a layer to a layer. After that, when the angle of incidence is greater than the critical angle, the light is totally reflected. When the angle of incidence becomes more than the critical angle, greater than the critical angle, it undergoes total internal reflection. And the ray is curved up. When the ray reaches the observer's eye, it seems reflected from water surface, and inverted image is seen below the objects. That's the explanation of mirage. When I ask you about, give reasons for the occurrence of mirage in deserts. Why? Simply, you can answer by these points. You have to mention first, due to high temperature. First, you have to mention due to high temperature in deserts. Due to high temperature in deserts, the air layers adjacent to the surface of the earth are heated, and their density and refractive index decreases. After that, if we follow a light ray reflected of a palm tree, what will happen? This ray refracts away from the normal and keeps deviating, taking a curved path. After that, when its angle of incidence reaches more than the critical angle, it undergoes total internal reflection and the curve goes up. That's for the give reasons. And here, as you see, another diagram for the mirage. So, what is the scientific basic of mirage? As you see here, total internal reflection when the angle of incidence becomes in the denser medium, becomes more than the critical angle, and the ray is totally reflected. That's for mirage. After that, look well, deviation of light through a triangular prism. Here we have a triangular prism. In this triangular prism, we have a light ray, here AB. When it travels from air to glass, yes, it is refracted and passes in BC. Then when it emerges from the glass, yes, it emerges like this, in this way, in CD. So here this is the normal, and this is the extension of the incident ray, and this is the extension of the emergent ray. So you have some angles, you have to memorize it very well. Which is here phi 1. Phi 1 here is the angle of incidence on the first surface. Phi 1 here, the angle between the incident ray and the normal line, as you see. Okay? Here, theta 1. Theta 1, angle of refraction. On the first surface. Okay. Phi 2. Phi 2 is the angle of reflection on the second surface. That's for phi 2. What about theta 2? Theta 2 is the angle of emergence. Here alpha is the angle of deviation, and it is the acute angle between the extension of the incident ray and the extension of the emergent ray. What's about A? A here is the refractive angle of the prism. A is the refractive angle of the prism. That's for this prism, this triangular prism. So I have a question for you. Here, when a light ray is incident on one side, give reasons for. When a light ray is incident on one side of a triangular prism, it may refract twice, emerging towards the prism base. Why? Here, because of this, the image of the object is seen through the prism, yes, displaced towards the prism vertex, as you see here, the light coming in this way, so you say it is displaced toward the prism vertex. That's for this diagram. So I can summarize the previous points in equilateral triangular prism. Here, this triangular prism is used in deviation and dispersion, of white light. Deviation, when a light ray passes in this way, then yes, it deviates. Dispersion, the white light disperses into 7 spectrum colors. Okay, phi 1, angle of incidence on the first surface. Theta 1, angle of refraction on the first surface. Phi 2 is the angle of incidence on the second surface. Theta 2 is the angle of emergence, is the refractive angle of the prism. Finally, alpha is the angle of deviation. Okay, so let's start by the geometry of the figure. The geometry of the figure, this figure, shows what? If you see to this geometry of this figure, here we have here this shape, we have here angle A, and this angle C, and these two angles equals what? Of course, here A plus C equals 100. A and C, A plus C equals 180 degrees. So, from this figure, A plus C equals 180 degrees. And here, angle A plus C plus, yes, this finally angle, these three angles equals 180. So we have here three angles of this triangle. Theta 1 plus phi 2 plus this angle equals 180 degrees. And here this angle and plus this angle, or this angle plus this angle equals 180. So by the comparison from this geometry, we can conclude that. What can you conclude? We can conclude A equals theta 1 plus phi 2. So A equals theta 1 plus phi 2. Why? Here A plus C equals 180. Okay? Also from the triangle, theta 1 plus phi 2 plus C angle equals also 180 degrees. So from the comparison between them, A equals theta 1 plus phi 2. This is very important relation. Okay? Also here in the previous figure, alpha equals angle 1 plus angle 2. Where is the angle 1 and where is the angle 2? Angle 1 here, this, yes, above here. Where is the angle 2? Angle 2 here. So alpha equals angle 1 plus angle 2. Alpha equals angle 1 plus angle 2. So from the geometry, angle 1 equals phi 1 minus theta 1. Angle 2 equals, yes, theta phi 2 minus theta 2 minus phi 2. So angle 1 equals phi 1 minus theta 1. Angle 2 equals theta 2 minus phi 2. So alpha here equals, yes, phi 1 plus theta 2 minus, as a common factor, phi theta 1 plus phi 2. Therefore, alpha equals phi 1 plus theta 2 minus A. So what's meant by angle of deviation? Angle of deviation is the acute angle. It is the acute angle produced between the extension of the incident ray and the extension of the emergent ray. At the end, I hope to understood the mirage phenomenon, the deviation in the triangular prism. Thank you and hope to join us in the next part, and goodbye.